So here's a slightly trickier example which involves a bit of two-dimensional motion knowledge. A ball of mass 2 kilograms is rolled along a smooth floor. Once it reaches a speed of 8 meters per second, it collides with an angled support beam which is 30 degrees to the horizontal. If the coefficient of restitution is a half, find the new speed of the ball in the form a root b, where a and b are constants. Now there are two ways of solving this problem. You could have it so that your diagram looks a bit like this, with the support beam here, and having the two walls where the support beam are, so it's kind of like a top-down view, like this, where you have this as your x-axis and this is your y-axis, and this here is 30 degrees. Or you could have it so that the support beam is your axis, and again from top-down view it looks a bit like this. So this is actually your x-axis, and this here is your y-axis. So both of the methods work. Pick one and try it, and if not, try the other method. And when you're ready, come back for the solution. So I actually made a bit of a mistake here as well, but nonetheless, we have our ball coming in at a velocity of 8 meters per second. The reason that this angle here is 30 is because this vector, if it's translated here, will have components of cos 30 in the x direction and sine 30 in the y direction, as is fairly common at this point. So the horizontal component of the velocity isn't actually changing because there's no impact occurring along the x direction. It's only along the y direction. So this 4 is the component of the velocity that's changing. So E is minus v over u. So we have a half is, or the magnitude of E more so, is vy, so our new velocity, over 4, which means that our new velocity in the y direction is 2 meters per second. Therefore, the velocity squared is the horizontal component, 4 root 3 squared plus 2 squared. And our final velocity is here as 2 root 13 meters per second. Now this might look slightly strange because our initial velocity was 8 meters per second, and our old speed was 8 meters per second, and our new speed is about 7. But that's because most of the speed is actually conserved in this 4 root 3. It is still going fairly fast, but most of the speed is actually maintained because no collision occurs along the point with the most speed, or with the most velocity. So if it were actually to occur along the y-axis, then of course the velocity would change slightly more than if it were to do in this particular situation.